So what was the balance of the account when Maria was 4? So I should probably say when she turned, like, on her 4th birthday, because she was 4 for a whole year, right? Which is why this is continuous, because we don't go from 3 to 4 on our birthday. Like, there's space in between. But when I say 4, I just mean like on her 4th birthday. So what was the account balance? Did you say $35,000? Yeah. Awesome. So $35,000. We found that by looking for an X value of 4, which gave us this point on the graph. And that gave us an approximate Y value, that wasn't a straight line, but pretend it is, of 35, which is measured in thousands of dollars. So we get 35,000. So then using that same idea, what is B of 4? So remember, the output associated with an input of 4 is whatever the Y value of that point on the graph is. So what's the Y value?
25,000.
So you're looking at the right place. This is one place where we have to be really careful. It's actually just 35. Because this is the point on the graph for 35. And this is one of those sort of subtle things that we have to deal with as far as labeling. The thousands of dollars is the units. So the number 4, or the Y, I shouldn't say 4 because we use 4 the other way. The number 35, or the Y value of 35, if we put units on that, becomes $35,000. But the Y value itself isn't $35,000. Does that make sense? So just like the units on our age are years, right? So it's 4 years. So the $1,000, I could even write it like this to make it a little clearer. So this is considered part of like the labeling of the number as opposed to like part of the number itself, even though in reality that means the same thing. Does that make sense? It's sort of a weird subtlety, but we see that a lot with larger numbers where we just take like thousands or millions or billions and make it part of the unit so that we're not counting such insanely large numbers. So then at what ages was the balance of the account $70,000? So are they giving us an input or an output here? An output, right? So we're looking for any points on the graph that correspond to a Y value of 70. So that's going to be here, here, and here. So that like says 8, 11, 13. 8, 11, and 13 years old. So notice that when we were given the output, it's totally possible to have multiple inputs corresponding to that single output, whereas the reverse isn't true because it's a function. If I give you an input, you can only find one point that goes with each input, right, because of the vertical line test. But horizontally, the same isn't true. I can have multiple places on the graph that pass through the same Y value. So if B of X is equal to 70, X is equal to what? Say it louder so everybody can hear you.
8, 11, 13.
8, 11, 13. So again, we're just asking the same question that we asked in part C, but using function notation rather than the context. Be really careful with like these things that have commas between them because like you probably wouldn't in this case because there's 3 of them, but if you put like parentheses around them or brackets, it turns it into an interval. So like if my answer was just 8 and 11 and I went like this, that would be saying that the Y value is 70 everywhere between those 2 points. So from 8 to 11, that the Y value is 70. And we see that's not true, right? It's just those 3 individual points. And so that's why we just list them. Theoretically, if you wanted to, just to like keep yourself from getting confused, you could put the curly brackets to say, okay, this is a discrete set containing only 8, 11, and 13. Although convention is, you'll usually see it more just like this, where we just list individual x values, as opposed to with an interval where we'll list them with the brackets to show that it's everything from one to the other. Okay, so apparently the estimated cost of 4 years of college at MSU for an in-state student is $84,000, which is shocking to me. But I guess probably not to you guys, because your whole lifetime it's been this horribly expensive to go to college, right? Like, that's apparently not even expensive. So at what ages does she have enough money in the account to pay for school?
16.
So she first has enough money at 16. That's exactly right. So that's right here. So we're looking for a y value of 84. And then everywhere above that, so older than that, maybe I should say, all ages older than that, she also has enough money. So when she was older than 16. And then when we get to F, which is asking exactly the same question, one clue that the answer is looking for an interval as opposed to individual x values is this word in. One a little too farther. They're saying x is in an interval as opposed to x equals individual values. So that's just like a little clue you can see in the statement of the question, that what we're looking for is a range of values as opposed to individual values. And that makes sense, right? Because it's not just on her birthdays of 16, 17, and 18 that she has enough money. It's all the times in between her birthdays also. We're going to, for the purposes of this problem, we're going to just assume that they took all the money out at when she turned 18, so we'll stop there. An argument could be made for it to keep going, but just to make things easier on us. So from 16, and I used a soft bracket here because on the graph it looks like it's exactly equal to 84 at 16, and that's a strict inequality, not an or equal to inequality. And so because of that strict inequality, I used a soft bracket. And so then we'll go up to 18, and I'm going to use a hard bracket here because at this point right here, the y value is greater than 84, right? So, so sometimes it'll be soft on one side, hard on the other, and that's okay. And then let's talk intercepts. So the y-intercept of any graph, regardless of if it's linear, nonlinear, whatever, is the point on the graph that crosses the y-axis. And we don't have one on this graph, but the x-intercept is any point, well, that didn't work out well, any point on the graph that pretend that's straight, that crosses the x-axis. So one thing to keep in mind about intercepts is that they're points, so they're ordered pairs. They have an x value and a y value. What is the x or the y-intercept on this graph? Where does it touch the y-axis?
0.
Yeah, so at a y value of 20, and we can see that anytime we're on the y-axis, the x-coordinate is going to be 0, right? We haven't moved to the left or the right, and so 0, 20. What does that mean in terms of the context? So in terms of age and money?
The accounts probably started with 20,000.
Yeah, so when she was born, they deposited 20,000, or when she was 0 years old, the balance was 20,000. There's a couple ways you can say that, but when you give things like this in context, you want to make sure to include information about both the x and the y value, right? If you just say the balance was 20,000. It doesn't say when the balance was 20,000, right? So you just want to include both components of that. So when she was born, the balance was $20,000. Any questions on this one? Yes.
So for F,
Mm-hmm.
it stopped at 18. That's because we know it's an H. If it had an arrow, would it just be 16 and infinity?
Yeah, if I had put an arrow here, then yes, it would go to infinity. That's exactly right.
What
Good.
if there's no arrow and it just goes, but like it's not an H, it could be a number that just keep going.
So if there's a point right here, then it stops.
Okay, so if there's no arrow, then there's point.
Right. And I mean, really, like, this graph was a little lazy on my part. Like, on tests, I will always give you an arrow or like a big black dot or an open point. Sometimes I get a little lazy when I know I'm going to be in class and I can say it out loud instead of like going in and messing with it. But yes, we'll double check things like that on tests to make sure that it's really clear if it stops or if it keeps going. Any other questions? Okay, so we're going to now take the context out of it and just do the same kind of analysis using our function notation. So the place where this can get a little bit tricky is knowing if we're asking for an x or if we're asking for a y. So if we want any information about a point on the graph, we have to either give you an x value or a y value. And remember that statement that we made earlier that, down here, there we go. F of x is equal to y. So you can think of this as like a template. So if you're given so if there is a number here, you're given the x value and the answer is the y value. So that looks something like f of x equals blank. I'm sorry, I didn't put a number there. F of like 4 equals blank. So you were given this piece of it and you don't know this piece of it. So you're looking for the y value. If there is a number here, you are given y, and the answer is x. So that looks something like f of x equals 4. So in all of these statements, you want to think of this as kind of like your template, and think about like there's like two spots. There's a spot in there for x and there's a spot in there for y. So which number is filled in, x or y? And then that's what you'll find on the graph, and then the corresponding value will be your answer. So let's start with domain and range. So this is just review from what we did last Friday. What's the domain of this function?
All real numbers.
Yeah, it's all real numbers because we go from an arrow on the left to an arrow on the right, and there's no horizontal gaps in between, right? That one potential place there could be a gap is a straight vertical shot from the closed point to the open point. We don't jump any x values. So good, that's exactly right. What about my range? So what y values are on there? So -1 is -1 included? Yeah, remember, even if there's not like the big black dot, that this is a point on the graph and it has a y value of -1, so it is in our range. So we're going to include that. And then going up from -1, what's the highest y value? Yeah, it's just 3. So this one's a little tricky because there is an arrow, but it's not an arrow pointing up, right? This thing levels off. And one thing you can assume is that if the arrow is going in a certain direction, it's going to continue doing that same thing. Like, there's not any weird stuff going on later. Yes?
How do you know that it was a hard bracket?
So, because there's not an open point right here.
Okay.
Like, every place on the curve is a point. We just, like, we can't put an infinite number of, like, big black dots, right?
Yeah.
So as long as there's not an open point there, then we assume that that's actually a point on the graph that we reach.
Okay.
Yes?
So how come if all of those are included on the line, how come the example before the 16 to the 18, how come the 16 wasn't?
Great question. Let me write this 3. Actually, I'm going to get back to that bracket. So the reason is that wasn't the range or the domain. It was the points where the y value is greater than 84. And at x equals 16, the y value is equal to 84, which isn't greater than 84, right? So the set 16 to 18 is the set of all the x values the set of x values that correspond to points on the graph where the y value is greater than but not equal to 84. And so so if this had been or equal to, this would have been a hard bracket because the point 1684 is on the graph. But at that point, the y value is not greater than 84. Is that how? Okay. I see another hand back there. No, okay. Okay, so coming back here, should the bracket at the 3 be soft or hard? This one's tricky. It should be hard. So the question you want to ask yourself, if you're ever in doubt about if you're going to include an endpoint or not, is if the endpoint satisfies whatever requirement it is that we're saying the things in that interval satisfy. So that's why here we said 16 wasn't in it because the y value is not greater than 84 at 16. But for the range, we're just asking ourselves, is there a point on the graph that has a y value of 3? And there's, in fact, like an infinite number of points on the graph with a y value of 3. So even though this point doesn't exist, because it's open, there is some points on the graph with a y value of 3. And so that means it has to be part of our range. Is that our entire range? We're missing one thing, right? What is it?
Do you have to do the U?
Yep. And then what's the other y value? So just y value. It's just -3, right? Because all the points on this horizontal line down here, it's true, like there's an infinite number of them, but all of them have the same y value, right? So that's probably the hardest part about this like domain range thing is like separating the x's and the y's and thinking of them independently. So in terms of the range, that horizontal line is like a single point because it only has one y value. And so that's where we use that discrete set. Yes?
So would the order matter here and where you put it on the side of the...
That's a great question. It doesn't matter. So with discrete points or discrete sets, the order within the set as well as where the set shows up in the overall answer doesn't matter at all.
Okay.
It's just sort of like throwing everything in the pot.
Gotcha.
The interval, of course, the order in the interval matters, but what side we put that discrete point, like what side of the interval we put that on doesn't matter. We're just like tossing in another y value. Good question. So yeah, we could totally write this as this as well, and it would mean exactly the same thing. Okay, so let's do some evaluating. What is f of negative 2? So we are given the x, right? So coming back down here, the number is inside the parentheses. So this tells me that x equals negative 2. So what's the y value that corresponds to an x value of negative 2? Which point exists? The one up above or the one down below? The one below, right? This is the point that exists. And so f of negative 2 is negative 3. What about f of 2? Yeah, that's positive 3. Again, they're giving us the x value. So that's this point right here.
Can you explain like the whole, for the one above, like the negative one? Like what do you mean by the one that exists? Is it just like the difference between the open dot and then the closed dot?
Wait, do you mean B? Oh, do you mean C?
I mean C.
Oh yeah. Yes, it's just the difference between the open dot and the closed dot. So the open point isn't actually a point.
Okay.
It's like the edge of a cliff almost. Like if you're coming from the right side and you're walking along that curve, before you actually get to that open point, you would fall and like, I don't know, it's like a black hole or something, like portal, that's the word I'm looking for. Like you go through that and end up down there at that big black dot. So the open point isn't actually a point with an x value of negative 2. The large black dot is a point with an x value of negative 2. So it's kind of weird because we can see it visually, but mathematically that open point doesn't exist. If we had some way of drawing the curve to get infinitely close to that without putting a dot there at all, like we would, but that's sort of the only way we can do it. Question?
How did you get negative 3 from negative 2?
So that's, so if x is negative 2, we're looking right here. And so that's what we were just talking about. This point doesn't actually exist because it's open. And so this is the point that's on the graph with an x value of negative 2. So this is the point negative 2, negative 3. So an input of negative 2 will give me an output of negative 3. And so that's just sort of something we have to start thinking in those terms, that anytime you see an open point, it's not actually a point on the graph. So now let's switch gears a little bit. We have f of x equals 0, which means that my y value is 0, right? If we say that f of x is equal to y, then whatever f of x is equal to is my y value. So y is equal to 0. How many points are there on this graph with a y value of 0? There's 2. Good. So right here and right here. So x is equal to either negative 1 or positive 1. And again, you don't want any brackets on there because it's not an interval. We're not saying that y is equal to 0 from here to here. We're just saying at those two individual points. And again, if you wanted to, you could put curly brackets to show it's a discrete set. But the typical convention you'll see, like what you'll enter in my math lab, is just the commas, no parentheses or brackets at all. Okay, so then these next two are similar to what we did with this less than or greater than 84. Here we're looking for every point on the graph that has a y value that is either above 0 or below 0. So we're starting with f. We're looking for where my y value is either equal to 0 or less than 0. And I think the best way to approach this is to kind of think of like if you, here's where y is equal to 0. That's impossible to see. There we go. This is where y is equal to 0, is on that line right there. And so if you start all the way on the left of the graph, so starting with this arrow right here, Is my y value less than or equal to 0 at that point? So think of it like a water line. Everything below that line is underwater and everything above it is out of the water. So at that point, am I under the water? Like when I say below, like you can literally think of it as below, like physically. Do you guys see where I'm talking about? So I'm going to start my solution with negative infinity. And now from that left arrow there, I'm going to walk along my graph. So you can, like, I always just say, like, actually take your pencil and trace from the left to the right. And you guys tell me when I jump out of the water. Have I gotten out of the water yet? Yes. Oh, okay, I did. A while ago, right? So when I hit an x value of what? So here's my jump right here. At an x value of -2, I jump from being under the water to above the water. So then I have to ask myself, at an x value of -2, is my y value less than 0? It's -3, right? Because we're at this point right here, which has a y value of -3. And so I'm going to include -2 because at an x value of -2, the y value satisfies this requirement. So far, so good? So now we've made the jump. We're up here. Now you guys tell me when we get below 0 again. Right there, right? At -1. At -1, is my y value less than 0? It's equal to it. So does that satisfy the requirement f of x is less than or equal to 0? It does, so I'll use a hard bracket. Put a union there. And then let's keep on tracing. So I'm below 0 now. When do I get above 0 again? Right there at 1. And at that x value, is my y value either less than 0 or equal to 0? It's equal to it. And so that point is included. And then if I keep on tracing, I never go below the surface again, right? Like everything else is above. So I want you guys to try G. One thing you can remember is that, oh, go ahead.
Why is E not an interval notation?
So because if I take all of the points with x values between -1 and 1, that's all these points. Those don't all have x values of 0. Y values of 0. Only the points at x equals -1 and x equals +1 have a y value that is equal to 0. So it's just these 2 points. It's not all the points between them. So an interval means left hand, right side, and everything in between. So when we say that my y value is less than or equal to 0 from -infinity to -2, that's saying that all of these points have a y value below 0 or equal to it. And then -1 to 1 means all of these points have a y value that is less than or equal to 0. So you guys try G. Keep in mind that you'll always either be above or below. So we found everything below. You're now finding everything above. Okay, so what is the smallest x value that gives me a y value that is above 0? You can give me the actual number even if it's an open point. We'll talk about that in a sec. Yeah, it's -2. But we know that the point at -2 right here isn't actually a point, right? And so we're going to use a soft bracket there. Because when x is equal to -2, this is the point on the graph corresponding to that x value, and that is not above, right? That does not satisfy this requirement. So walking along my graph, oops, there we go. When do I stop being above 0? At -1. And then I have to ask myself, whoops, wrong color. At an x value of -1, is my y value greater than 0? It's not, right? It's equal to 0. So I can't include that. Sorry, my negative got really tiny there. There we go. So again, that's a soft bracket, and that's because this is strictly greater than as opposed to or equal to. If it had been greater than or equal to, because at that point, at this point right here, y is equal to 0. And the things in my set aren't allowed to have y values of 0. They have to have y values that are positive, right, above 0. So where do I start up again?
1.
At 1, good. Should I include 1?
No.
Everybody agree? Should I include it? Should I not include it? So remember what the requirement is. The y value has to be greater than 0 if I'm going to include it. We're not going to include it because at this point, the y value again is equal to 0. It's not greater than 0. And then I'm going to go off to infinity, yeah. Because all the points following that right arrow are going to be above. So these brackets can get a little hairy, but what you want to always ask yourself when you get to an end point, so a point where you're going to stop your interval or start your interval, ask yourself if that specific point, so this point right here, if the y value of that point satisfies the inequality or not. So up here at -1, the y value was less than or equal to 0, and so that's why we included it. Whereas down here, the y value is not greater than 0, and so we did not include it. Does that make sense? These definitely take a little bit of practice to think through that whole thing. One thing that is sort of misleading is we're sort of used to looking at pictures and being able to just kind of grab whatever answer we want off of it. And like this process, you kind of really have to think through like each individual piece of your answer. You can't just kind of look at the whole thing and like just know the answer, right? You have to kind of think of it as like moving along the graph and asking yourself what happens at each individual point. So let's get rid of all these scribbles. Okay, what's my y-intercept? As an ordered pair? Zero. Yep. And notice that these ordered pairs can look a lot like intervals. So it's all just about context. So intercepts are points. So they have an x value and a y value. As opposed to this guy, those are all x values, right? When we have an interval, we're saying that my x values are going from -2 to 1 to -1. And we know that because of this statement right here, that those are all x values. As opposed to intercepts are always ordered pairs. So they always give you an x value and a y value. It's tricky because they look exactly the same. So it's all about context, the context of the problem that we're in. What are my x-intercepts? -1, 0, good, and 1, 0, perfect. And that's something you can do also as far as these two, which I think are probably the most challenging of all of these, is if you can find your x-intercepts, then all the places where your y value is below or above, all those intervals will be in between your x-intercepts, right? So if our x-intercepts are right here, well, this jump changes things a little bit in this particular problem because we jumped over the x-intercept. But if you think of connecting that like so, we have one interval here, one interval here, one interval here, and one interval here, and we go like up, down, up, down, up, down. So those x-intercepts can give you an idea of where these endpoints are, like where those numbers are, where you're going to start and stop being above or below. Question? Yes.
Yeah, so if we're trying to include the y and x-intercepts,
yes.
why would they not be bracketed?
Great question. It's because they're not intervals. It's because they're ordered pairs.
Okay.
So those aren't brackets in the same sense that they're brackets in interval notation. And I totally get that that is weird because they look exactly the same. Again, it's all about context. Only intervals use either a soft or a hard bracket. Ordered pairs are always just in parentheses. So it's an x value, comma, a y value in the parentheses. And really, for our purposes, the only time we'll actually use ordered pairs are at the intercepts. I'm trying to think of any other situation on a graph. Every once in a while, I'll ask you, like, I'll just be like, give me one ordered pair on this graph and then have you interpret it. But in a setting like this, the only time we're going to have ordered pairs is for our intercepts. And everything else is going to be an interval or individual x values or individual y values. Oh, well, that just took up our whole thing, but that's good. We had such good discussion. I love